page of our Unit 4 review. So we're looking at number 9. It says, given ray BD is an angle bisector, what is the value of X? So in this image, we have to know what an angle bisector does. It says BD is the angle bisector. What does bisect mean? Split in half, exactly half, 2 equal pieces, yes? So if it is an angle bisector, it's splitting the angle in half, agreed? So the angle here is ABC. That's the one that's being cut in half. So that means that this new angle, ABD, is going to be congruent to this angle, DBC. So if those are congruent because of this angle bisector, what does congruent mean? Equal, the same. So when I set up my equation, I'm going to set them equal. So I can do 5x minus 22 equals 2x plus 35. Or I could write the 2x 35 on the left and the 5x plus minus 22 on the right. It doesn't matter which side they're on, just that they are equal. Okay, and then I showed y'all in Desmos, instead of going through and having to do this algebra, you can use Desmos. You pull up a Desmos window. And it will it'll do the algebra for you, right? Do y'all remember this that I showed you? So I'm going to type it in once I set up the equation. So the geometry part of this was knowing what an angle bisector is and what it means. And it means that these two are equal. So now that I know that, I can type this in. And the next part is algebra. The actual solving of this is algebra. So Desmos will not do the geometry for you. It won't set it up for you, but it will do the algebra for you. So if you type in your equation, as long as you have got it typed in correctly, it's going to show you the solution, what X equals. Now, I don't see anything on this graph right now. That means I need to zoom out. It must be bigger than 10. So just keep zooming out until you see a line. So now I see the line, okay, and I can click. I'm looking for where it crosses X because that's the X value. So X is 19. Everybody good? So yes, you can come over here and actually work it out. But again, you can use Desmos here. So I'm going to put use Desmos. Once I set that up, I use Desmos. And I get that X is 19. Is the question asking for X? Yeah, I go back and read and make sure. And it says, what is the value of X? So I'm done. X is 19. Now, some questions don't ask for the value of X. That's why it's very important that you go back and read. If the question said, find the measure of angle ABD or DBC or ABC, what would I have to do? What would I do with this 19? I would plug it back into these expressions. I would do 2 times 19 plus 35 to get ABD. Or I would do 5 times 19 minus 22 to get DBC. What if they wanted ABC, the whole big original angle? I'd have to add those together, wouldn't I? Once I found those individually. Now, a way to check your work. If you're unsure if you did it right, and you know these are supposed to be equal, if I do plug this 19 in for these, okay, and I can do this in Desmos. If I plug in 5 times 19 minus 22, it tells me that that little angle should be 73. And then I can check the other side. 2 times 19 plus 35. Okay, that also comes out to 73. So that's a check because they should come out equal, shouldn't they? And if it asks for the big angle, you can either do 73 plus 73, or you could do 73 times 2 because there's two 73-degree angles. So whether you add the two angles or take one of them and double it, you get 146 would be ABC. Are we all on the same page? All right, let's look at 10. In number 10, it tells us that MN is a median. Okay, so this is not an angle bisector. It's not cutting that angle M in half. It is a median. Who remembers what a median does? Say it again, OPEX. It doesn't divide the triangle in half. These aren't going to be congruent triangles, but it divides something in half. And it's not the angle. It's not an angle bisector. So what else could it be dividing in half? That segment down there at the bottom, this segment KL, a median connects a vertex, which is M. That's one of the corners of your triangle. It's called a vertex. Okay, to the midpoint of the opposite side. So the fact they tell us this is a median tells us N is the midpoint. So that means that K to N is going to be equal to N to L. So it cuts that segment in half. So far, so good?
So they are equal?
So those two segments are equal. So I will set 9x plus 33.
Wait, so anything that's a bisector and a median?
But it depends. An angle bisector means these angles will be equal. A median means these segments will be equal. If you have a perpendicular bisector, it also cuts the segment in half, and so the two halves would be equal. So yeah, you have to know your terminology, what these different terms, these special segments. And if you need to go back, if you're forgetting these, this was in section 4.4. 4.4 was special segments, angle bisector, perpendicular bisector, median, and altitude. Okay. Then 4.5 was mid-segment, which is also a special segment, but we'll get to later in the review. Okay, so 4.4 and 4.5 talked about this, all the special segments and triangles and what they do in the triangle or what they connect. All right, so I'm going to finish setting this up. So 21x plus 9. So again, I'm going to use Desmos to do the algebra, but I had to know what equation to set up. I had to know that these were equal to each other. So now I'm going to pull up Desmos and plug this one in. Zoom in. No, not going to zoom in for me. Okay, let me clear this out from the last problem. So this one is 9x plus 33 equals 21x plus 9. And there I can see, and remember, if you hit this home button, it'll go back to your little 10 by, 10, negative 10 to 10 window. Okay, so you can zoom in and go back to your home screen if you want to. So we can see that this one means x is 2. Okay, so when I come back over here, I'm going to say, okay, I used Desmos and I found that x is 2. Now, is this one asking for x? No, I go back and read carefully what the question is asking for. They're asking for the length of NL. So N to L is right here, 21x plus 9. So I have to take that x value and plug it back in. X is 2. So I'm doing 21. That's 21x means 21 times x, right? So I'm doing 21 times 2 plus 9. And you can use Desmos. You don't have to do this in your head. So 21 times 2 plus 9. So that segment should be 51. Now I could confirm this by also plugging it into the other side. 9 times 2 plus 33. That's also 51. So 51 are each of these halves, which is what it was asking for. It was asking for just N to L. So 51 is your answer. If they asked for KL, what would you do? They wanted that entire segment, K to L. I would have to add 51 plus 51. Good. So read what the question is asking for carefully. 11 says, which of the following could represent the side lengths of a triangle? Check all that apply. So we said in the triangle inequality theorem, this was in 4.6, if you need to look back at your notes, okay, that you have to have a triangle, the two shortest sides, I write this out again, the two shortest sides must add to be greater than means bigger than, right? More than. If you want to write bigger or more, that's fine. Greater than the longest side. Okay, so I'm going to color code this just like I did those words. Okay, and it's the same color coding I used in our notes. So I'm going to find for each of these, because it says check all that apply. So I have to check all of them. So I'm going to circle the two shortest sides of each group of numbers. So 19, 11, and 17. 11 and 17 would be the two shortest. What do those add to? Okay, so is 28 greater than, less than, or equal to 19? Greater than. And is that what I wanted? Yeah. Yes. So A can form a triangle. So then I'm going to do the same thing with B. What are the two shortest sides? 23 and 28, right? And I'm going to add those. So that's what? 40, 51. How does 51 compare to 52? It's less than. So B cannot form a triangle. Nope, doesn't work. Are we on the same page? Do you understand what we're doing? Yes, no, maybe so?
Yes.
Okay, so what are my two shortest sides in C? So I need to add 9 plus 25. What's 9 plus 25? 34. So how does 34 compare to the longest side, which is 34? Those are equal. Is equal the same thing as greater than? No, so this cannot form a triangle. Equal doesn't work. It has to be greater than. All right, what are my two shortest sides in D? What do 13 and 14 add to? So 27. How does 27 compare to the longest side, which is 22? 27 is greater than 22. So that one can. So that's, you can put a check or circle it if you have room. Okay, so far we've got A and C work. Okay, now E, we need to check 12 and 6 are my shortest sides. What's 12 plus 6? 18. How does 18 compare to the longest side? They're equal, so that cannot form a triangle. And then the last but not least, 8 and 14 add to what? How does 22 compare to the longest side of 21?
It's great.
It's greater than. So that one can form a triangle, right? So we had A, D, and F can form a triangle. Feel okay about that theorem? The two shortest sides must add to be longer or greater than the third side. All right, so this one says the lengths of two sides of a triangle are 26 and 48 meters. What is the range of possible side lengths in meters for the third side X of this triangle? So X is the missing side. We don't know if it's supposed to be the longest, the shortest, or the middle length. So we have to find a range of possibilities of what it could be. So we said, when we do this, you have to take your two known sides and we need to add them. So what's 26 plus 48? We're going to add 20, we add the two sides, we get the sum. 74. Now, if these were the three sides of my triangle, 26, 48, and 74, that wouldn't work, would it? Because the two shortest sides would add to be equal to the third side. So it can't be 74. It's got to be less than 74, the third side. So 74 is that upper end of the range. Okay, this is your sum. The sum is when you add. Okay, then we have to find the difference. So take your bigger number minus your smaller number. So 48 minus 26 is 22. So if 22 was the third side, 26 and 22 would add to 48. So it can't be exactly 22. It's got to be greater than 22, which is what this inequality says. So you're finding the difference. That means subtract. And you're finding the sum. That means add. And then that third side has to be somewhere between those numbers. See, this says that X has to be greater than 22, but less than 74. Does this make sense? Okay. So you add and subtract to get your range of possibilities for the third side. All right, in 13, we've got this image. What did we have one kind of like this on the quiz?
Yes.
Yes. So we've looked at this before. So let's try it again. Okay, so we've got angles 1, 2, 3, 4, and 5 are missing. We want to know what those are. So we have to use what we know about angle relationships and triangles, which the big one that you need to know is the triangle angle sum theorem. What do the three angles of a triangle always add to? Good. So the triangle sum theorem, a quick little short abbreviation, says that the triangle sum, that means the three angles in the triangle, have to add to 180. Okay, we have to know that. Okay, so look, and the other thing we have to know are linear pairs. Okay, guys, I need the side conversations to stop, please. So a linear pair means if two angles form a line, it's 180, right? So here I've got a line. And I know one of the angles is 138. So could I use that to help me find this interior angle here?
Yes.
Okay, so what would I do?
You would.
Good. 180 minus 138, because they're a linear pair. They form a line. A line is 180. If you need to write that at the bottom too, line is 180. Or you can write linear pair equals 180. That's the other piece that we need. Okay, so those are like the two main rules that we're using for this type of question. So 180 minus 138 leaves us with 42. So this angle is 42. Now that's not one of the ones we were asked for, but we need it to help us find the ones we're asked for. Because now I can look in this triangle and I have two of the three angles of this triangle. So how can I find the third angle? Yeah, these two have, and all three of these have to add to 180. So I'm going to take 42 and 68 and add those together and then subtract that from 180. Or you could just do 180 minus 68 minus 42. Whatever order you prefer to do that in is fine. But that leaves us with 70. So this angle is 70. So far, so good? Now, angle 5 is one that we need. And I know it now. How do I know angle 5? Not corresponding. When they're across from each other at an intersection, when you have two segments or lines intersect, vertical angles. Okay, and what do we know about vertical angles? They're the same, they're congruent. So vertical angles here. So 5 is also 70. So I know angle 5 is 70. So that's one of the answers I needed. Now I can't find 4 yet, because if I look at this triangle, I only know one of the three sides. So I need to come over here and see if I can find anything. Could I find angle 3 with that same linear pair concept? Yeah, because these two form a line, don't they? So I could do 180 minus 124. That leaves me with 56. So angle 3 is 56. Now can I find angle 4? Yeah, because now if I look at this triangle down here, this blue one, I know 70 and 56, and I know the total has to be 180. So again, I can add 70 and 56. And subtract that from 180. And see what's left for that angle 4, which would be 54. So this must be 54 degrees. So far, so good? This red again. I highlighted, the red went away. All right, now let's look over here. We still need angle 1 and 2. How could I get angle 1? What is this happening here?
180.
Yeah, it's a line. So that's also going to be 180 for a linear pair. So 180 minus 61 is 119. So angle 1, 119. All right, last but not least is angle 2. In this triangle, if I'm looking in this other triangle, let me color this one in pink. If I'm looking here, I need angle 2. Right now I only know the 61 degree angle. Couldn't I know because of vertical angles here that this is 56? So because, oh, you cannot see that red on pink. 56, because these are vertical. I guess I better put 2 arcs because I put 1 over here. So this is 56 and 61. So I can find angle 2 using the triangle sum theorem that says, okay, if I add 61 and 56, I've used 117 degrees. And then if I subtract that from 180, that leaves me with 63 degrees. So angle 2 must be 63 degrees. Okay, so it looks like there's a lot of work here, but it's all just adding and subtracting, right? It's not complicated math, and you get Desmos, so you can type all of those into the calculator. It's just adding and subtracting, but you have to know the angle relationships. You have to know linear pairs. You have to know vertical angles, and you have to know the triangle sum theorem. We feel okay about that one? Now, some of you may notice something, some of you may not. I'm going to point it out because it does save you some time if you know it. But notice how over here in this yellow triangle, when we were looking for 70, see how 68 and 70 add up to this exterior angle 138? Okay. And over here, this exterior angle 119, 63 and 56. Those add to 119. So if you have an exterior an angle outside your triangle, it's always going to be the sum of the opposite two interior. So if you know that, you could just do 138 minus 68 and get 70 without having to find this 42 first. So you can do it how I showed you, but if you realize the exterior angle is always the sum of the opposite two interior, it could save you a little time. If you don't remember that for during this, that's okay. You can do it how we did it. Yeah. All right, last couple on this page. Okay, so number 14 is asking us to name the special segments. Okay, again, this goes back to these. This is from 4.4 notes. The special segments we learned, the 4 were altitude, angle bisector, perpendicular bisector, and median. So we have to know the difference in those and what they look like in the markings. So remember that at the top of this, we said that a median connected a vertex to the midpoint of the opposite side, right? So which one of these looks like a median? It connects a vertex to the midpoint of the opposite side. That second one, see, it's a vertex. And I know that this is a midpoint because of these markings. So vertex to midpoint is a median. If you want to write under that, vertex to midpoint. And abbreviate midpoint. Okay, what about that first one we did at the top of this page? Number 9, we talked about an angle bisector. It cuts an angle in half. Which one of these looks to be cutting an angle in half? Yeah, that last one. See, it's the only one with markings on the angle. It says that this little angle has 2 arcs and this little angle has 2 arcs. They're congruent. So this one is an angle bisector. Okay, and if you want to put underneath, it cuts the angle in half. All right, so we haven't had these other two on this page of the review, okay? But what is happening in this one? This CP segment, it's making a 90-degree angle, so that means it's perpendicular, right? And what do these tick marks tell us? That those are the same, so that means that this point P is the midpoint, right? So this segment CP, it's bisecting AB, it's cutting it in half, and it's perpendicular. So that's the name of it, perpendicular bisector. Perpendicular bisector. And you can put in parentheses, it makes a 90-degree angle and cuts the side of the triangle, the segment, in half. Now this perpendicular bisector happens to be going through the vertex C. Not all perpendicular bisectors do. It could be like off to the side. If this happens to be an isosceles triangle, that's why it goes through the vertex, but they don't always. All right, and then last but not least, the only one that we're left with that we haven't talked about on this page is altitude. The altitude, remember, is like the height. How about I spell it right? Of the triangle. And remember, base and height, when you did area way back when, base times height for area of things, they always have to meet at a 90-degree angle. So that's what an altitude does. It connects it does have to go through a vertex and connect to the opposite side at a 90-degree angle. So vertex to the opposite side. Why does it keep erasing? At a 90-degree angle. Now, saying that, didn't this perpendicular bisector in this example also connect a vertex to the opposite side at a 90-degree angle? Mm-hmm. So this is technically also an altitude. So this one is both. So I'm going to put altitude also. Or altitude too. Now, not all perpendicular bisectors are altitudes, only if they go through the vertex. Okay, I think I'm just going to show you one. I know we haven't done it, but I'm going to try to show you a picture somewhere else. Like here, okay, they told us some information. See how this segment doesn't go through the vertex? It doesn't touch that vertex. Okay, that is not an altitude because it doesn't go through the vertex. Even though they tell us that these are perpendicular. Oh, and it actually doesn't tell you that, but it's supposed to. But this is going to be a perpendicular bisector. because it's going to cut this side in half and make a 90-degree angle, but it is not going through a vertex, so it's not an altitude. So sometimes your perpendicular bisector is also your altitude, but not always. So you just got to make sure if it is going from a vertex to the opposite side at 90 degrees, it is an altitude. But this one, an altitude does not bisect the other side necessarily, okay? All right, last one on this page. Finding the missing angle. This uses what we said up here. The triangle sum theorem, that the three angles have to add to 180. That's all we're doing right here. We're saying in triangle 1, if I know these are two of the angles, how can I find the third? I can add the known angles, the two that I know, and subtract from 180, right? Or if you prefer, you can just write it. I'm going to do the work down below here, if it will let me. You can just write 180 minus 117 minus 49 and just do the double subtraction, or you can add them first and then subtract, however you prefer to do that. And you can do that in your calculator, and there's only 14 degrees left. So that's 14 degrees for the third angle. I'm going to do the same thing for triangle 2. I'm going to take 180 and I'm going to subtract the 36 and the 87 that have already been used. And that leaves me with 57 for the third angle, the missing angle. And then in triangle 3, I'm going to do the same thing. I'm going to subtract the two that I know, 99 and 56. And I'm left with 25 degrees for the third angle. Now on your quiz, y'all had something like this, right? But it also asked you to classify. And so I know the review doesn't, but I want you to be able to classify a triangle. Look at this. This angle is bigger than 90, isn't it? What type of angle is that?
Obtuse.
Okay, so this is an obtuse triangle because the angle is bigger than 90. Now, are any of the angles the same? No. So that's also, we know all the sides will be different lengths because all the angles are different. So it's going to be scalene. So this is an obtuse scalene. Okay, triangle 2, are any of these angles 90 or bigger? So what are all of them? They're all acute. They're all less than 90. So this is an acute triangle. And are any of these the same? No, so this is also scalene. So this is acute scalene. And then this last one, are any of these 90? Well, not exactly 90. So none of them are 90 exactly, but this one's bigger than 90. So what is it again? Obtuse. And are any of them the same?
No.
So this is another obtuse scalene. So all of these were scalene because all three angles were different. Remember, for it to not be scalene, you'd have to have two sides equal. It would make it isosceles. And so two of the angles would be equal. Or if all three are the same, so all three angles are equal, means all three sides will be equal. That's equilateral. Okay, so none of these were. All of these were scalene. All three angles were different from each other. But obtuse has one angle bigger than 90. Acute, all three are less than 90. If you have an angle that's exactly 90, you have a right triangle. Do we feel okay about those? All right, I'm going to stop this video here. The other two pages will be in separate videos. You can check and watch those later.